Hey guys, so today we'll be solving LEET code number 1975 maximum matrix sum. So let's see what the question states. You are given n into n integer matrix. You can do the following operation any number of times. So we have to do this operation any number of times we can, but we have to reach to a conclusion. Let's see what the question actually states. The operation is choose any two adjacent elements. What is adjacent elements? Let's see in this example. Matrix 1 minus 1 minus 1 1. The adjacent elements are the side by side or top bottom ones, not the corner ones. These two are adjacent elements. These two are adjacent elements. These two are adjacent elements. These two are adjacent elements too. So choose any two adjacent elements of matrix and multiply each of them by minus 1. We need to multiply each of the adjacent elements by minus 1, not only this element. Like you can't take only this element and multiply it by minus 1. You have to take both of this and multiply it by minus 1. So these are the this is the operation we can perform. We are allowed to perform to reach to a certain conclusion. So what is the conclusion now? Two elements are considered adjacent if they share a border, which I have just told you that they have to share a border. Your goal is to maximize. Now, this is the thing we have to achieve. Your goal is to maximize the summation of the matrix's elements. Return the maximum sum of the matrix's elements using the operation mentioned above. So, we can perform these operations any number of times. The question doesn't care about that. It only cares about we have to maximize the summation of the entire matrix's elements, and we have to return the maximum sum of the matrix's elements using the operation mentioned above. So, if we take a closer look at the example 1, let's simulate the entire process. 1 minus 1 minus 1 1. We are taking these two adjacent elements for the first operation, and we perform the operation. After performing the operation, which is multiplying by minus 1. So 1 multiplied by minus 1 becomes minus 1. Minus 1 multiplied by minus 1 becomes 1. So the matrix becomes minus 1, 1, minus 1, 1. These two remain same as we haven't taken these two elements. We have performed the operation on these two adjacent elements. Now we need to take these two adjacent elements, minus 1, minus 1. So after taking these two, what we are getting is 1, 1, 1, 1. So the negatives, all the negatives are there is what I can say. All the negatives are vanished from now here. So now what we are getting as the sum of the matrix. Now the sum of the matrix is 1 plus 1 plus 1 plus 1, which is equal to 4. Now the output is 4. Let's take a look at the example 2. 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 2, minus 3. These two adjacent elements, let's convert them into minus 1. So this becomes positive element. It doesn't do anything. Just make the negative elements positive elements. If minus 1 is multiplied to a negative element. So these two becomes 2 and 3. Minus 1 remains the same. Now if we calculate the entire matrix, it becomes the sum becomes 16. We are needed to only provide the sum of the matrix. So can we have some observations? We have some questions to ask. If we have to maximize the summation of the matrix's elements, which type of elements we need to consider to make sure the total sum of elements get as less damage as possible? Just read it carefully again. We need to maximize the summation of the matrix's elements, right? So what we need to do is we need to eliminate the negative elements. How we can eliminate the negative elements? That answer is in this operation. If we multiply a negative element by minus 1, it becomes the positive element, right? So we need to consider the negative elements. We only need to consider the negative elements of the matrix so that we can achieve a maximum possible sum. So we get it. Now, in the question number 2, we have to ask if we have even number of negative elements. Now let's think about it. If we have even number of negative elements, here we had even number of negative elements. Can we eliminate all of them regardless of the fact that they are adjacent or not? It will be odd, sorry. So, regardless of the fact that they will be adjacent or not, can we? Like here, let's show you an example. Here is the example I have prepared for you. Look, take a closer look. The matrix is minus 34, 43, minus 23. These two, these two are the negative elements. And in this matrix, there is even number of negative elements. The number of negative elements in this matrix is 2, which is an even number. So we need to eliminate these two. How we can? Because these two aren't adjacent elements. But can we say that performing a certain number of operations, we can make these negatives into and two adjacent elements, and then if we perform the same operation on these negative elements, negative adjacent elements, then we can get the positive elements. Like how this happens, right? So minus 34, 43, minus 23. Let's take a look. We are taking minus 34 and minus 34 and 43, these two elements, and perform the operation. What is the operation? Multiplying by minus 1. So after multiplying minus 34 by minus 1, it becomes 34. 43 becomes minus 43. Minus 23 remains the same. Now, can you see the magic? Minus 43 and minus 23 are adjacent elements now, and both are negatives. If both are negatives, we can perform the operation by multiplying by minus 1. So minus 43 becomes 43, minus 23 becomes 23. Now, so the even case is clear for us, right? That if we have even number of negative elements, we can eliminate all of them regardless of the fact that they are adjacent or not. And at the end, we have to send or we have to return the total sum of the matrix's elements. But there is a catch. If we get odd number of negative elements, what will happen if we get odd number of negative elements? We will be always left with one negative element. There is no question about it that we will be left with one negative element at the last, because we just saw that in the even number of case, we always can get it to the all positive elements. But if we have one element, negative element left at the end, then it will, regardless of the fact, whatever happens, it will hamper our total sum. So, how we can minimize the damage to ensure the least damage on the total sum? Take the smallest absolute value as the element to deduct from the total sum. Now, what does it mean? Let's take an example. Minus 100, minus 100, minus 100, 2. So, there is odd number of negative elements in this matrix. Now, what we need to do is we need to consider this element 2, because it is the smallest absolute, what does it say? Smallest absolute value. Smallest absolute value in this matrix. So, to take this negative into this, what you can do is minus 100, minus 100. Let's perform the operation in these two adjacent elements. It becomes 100, 100. Minus 100 remains same, 2. Now, let's perform the operation in these two adjacent elements. So, it becomes 100, 100, 100 minus 2. So, can we say without performing this operation, we can just sum up the entire matrix and just minus it by 2 into the smallest absolute value as the element. So if we just sum it up, 100 plus 100 plus 100, 300 minus 2, 298. So we will get 298 as the sum of the matrix, which is the maximum possible sum for this matrix after performing this operation. So can we code it up? Let's see. First, what we need is, let's take n equal to the size of the matrix. That's the normal thing. And we have to take a variable called mini. Mini is the smallest absolute value of the matrix. Let's initialize it by int max so that it can get reduced quickly. And now, what you need to we need to keep a count of the negative. The negative count, let's initialize it with 0. And we need to keep a count, sorry, we will be needing a variable sum of elements equal to 0. Now, let's traverse into the matrix. I guess all are familiar with the traversal in the matrix. We will be needing two loops. If matrix of I, comma j is lesser than 0, that means it's negative, then we have to increase the negative count. Now, sorry, what we'll be doing again is we will be add up all the matrix's elements absolute value to the sum of elements variable. Remember, it's the absolute value. And what will be mini? Mini will be minimum of mini make sure it's the absolute value because we just talked about it, right? That we have to take the absolute value, smallest absolute value, which will be the mini. Now, what we need to return if we get even number of negative count, if we get even number of negative count, we can return the sum elements as it is. Else, if we get odd number of negative counts, we can return the sum of elements minus 2 into 2 into mini. Because we just talked about it, right? That we have to negative the one negative element will be always will be left if in the odd number of negative elements case. So we have to multiply it by 2 because in the summation some of the elements of the matrix we have look here we have taken absolute value of all the elements of the matrices. So the if we have taken all the absolute values, then the negative value we are considering here is also added up considering the absolute value here. So we need to negative it two times. So 2 into many. And now for the not overflowing, we are taking here 2ln. So let's run it. It should. Yeah, it runs. Let's submit it. Yeah, it's accepted. Runtime is okay. Okay. Memory is okay. Okay. Thank you.